Hi everyone, my name is Nicolette.
And I'm Sarah.
And today we're going to be talking to you guys about the parametric test, which is Kruskal-Wallis. So basically, we're going to first look at the definition from the book. So the Kruskal-Wallis age statistic is a non-parametric hypothesis test used when there are more than two groups and a between group design and also an ordinal dependent variable. So another way to look at what really a Kruskal-Wallis test is the tree that Professor Shirey introduced to us in class. And basically where you can find it is three categories at independent variable, and it's two variables and they are independent, but the major thing between a one-way ANOVA and a Kruskal-Wallis is that Kruskal-Wallis is not a normal data, whereas one-way ANOVA it is. So a one-way ANOVA is more powerful than a Kruskal-Wallis, but once again, we only use Kruskal-Wallis when our data is not normal. So now what we're going to do is, I think that the best way to really understand how to do these problems is to actually do an example. So on the last test, test 4, we had a problem that says Leah wants to calculate a Kruskal-Wallis age test for the following data. The independent variable is major and the dependent variable is test score. Please calculate age and state the critical value. You do not have to come to a conclusion about the null hypothesis. So basically what we do for this is Kruskal-Wallis to me is something like a Friedman, but instead of going like by rows, we're just going to do all the data together. We're going to rank. That's step 1. Step 1 is to rank all of our data.
Here's our data for the 4 groups.
Now we need to rank the data.
Once our data is ranked, we are going to add the rankings and total each row. Now that we have our total for each ranking, we're going to plug these rankings in to our equation.
So when we solve Kruskal-Wallis, the formula we're going to use is the age statistic, and it's 12 over n times n plus 1 times the sum of rj squared over little j n minus 3 times n plus 1.
We're going to start by plugging in our total number of subjects times the number of subjects plus 1. Now we've plugged in our ranking totals, and underneath is the corresponding subjects for each row, and we're going to go ahead and solve from here.
So the total of all these numbers added together is 1327.13. So when we do 12 divided by 272 times 1327.13, we get 58.55. Now what we're going to do is we're going to plug in 3 times 17, which is at the end of our formula, and that's 51. So it's 58.55 minus 51, which gives us our age statistic of 7.55. So now it comes to the part that we're going to look for our critical value. And how we find the critical value is that we're going to go on our chi-square distribution table, and we're going to find the degree of freedom. Now, so the degree of freedom for the Kruskal-Wallis is k minus 1. So how many groups did we have? We had 4 groups, minus 1, which is 3. We go on a degree of freedom and we see that it's 3, and our significance level is 0.05, which is usually what it is. So we're always going to go to 3 and we're going to go to 0.05, and we see that our level is, our CV is 7.82.
Since our age stat is less than our critical value, we're going to end up failing to reject.
So now that we're done with our problem, as you can see, it's actually really easy to do the Kruskal-Wallis test. And remember, we use this when we can't use the one-way ANOVA because our data is not normal. Thank you so much for watching, and hopefully we'll have more videos for you guys. Bye!